well. We've had a good weekend and then a good Tuesday off. It's been a minute since I've seen you all.
It really has. It really has been a long time.
Yeah, you guys, yeah, it would have been 8 weeks since I saw you guys last. So, and you guys can keep working amongst yourselves, don't worry. Let's see. The Magnetism homework is, when you look online, it says it is currently due tonight. However, after talking with the previous class and looking over a few things, I've decided to swap out a few of the questions because the ones that, some of the ones that were in the homework, there were two in particular, that when I first glanced through them, they were about specific principles, and that's why they were included. On a second glance, I realized that while they are solvable, if it takes me longer than a minute to figure out how to do it, it's not fair for you guys. So I've swapped a couple of them out for versions that require a little bit less work, but use the same principles. And I don't want to make it due the same day that I changed it, in case you guys thought you had it finished, or in case you were confused by some of them, and now we need to rework a few things. So I'm just going to make it tomorrow night, just in case.
Thank you. Thank you. Are they already changed on here?
Yes, it should be. At least one student reported that already. So, main thing I'd like us to do today is take a look at some of these questions. I've already got some information about, let's see, which number is that one now? Whatever number it was to begin with, it's number 5 now, the double wire question. I've already got that one up on the board. I'd like to talk a little bit about it.
I didn't know how to do that.
You did?
Did not.
Good. Well, okay, not good, but good with a happy craft.
Lady, I was going to pretend, how angry are you?
I'm changing the homework that we do tomorrow since I changed a few things. Quiz as well, for fairness sake. Additional miscellaneous announcements. I will be posting information on test review. The test will be, the electricity and magnetism test will open next Tuesday. You'll be invited at any point between next Tuesday and next Friday. To help facilitate that, and because of Mother's Day, there is no lab next week. All lecture next week will be dedicated to answering a few questions and probably beginning to meander into topics about waves. That's the last thing I definitely want to cover with you guys this semester. And I'm just rambling at this point. Main thing for today right now is just looking at the homework assignment, making sure everyone feels good about that. If we get to a point where we don't have any questions about that, we will turn our attention to the test review materials that I will be uploading to Brightspace today. I try to upload a finite list of topics that you need to know, and B, practice questions. So those will be up today. So, all that said, let's take a look at the homework. How many people looked at this and were confused? That is okay. I'm a little frustrated because when I worked this before, this number was different, so that's going to change the work I have on the board just a tiny bit, but we'll roll with it. So, we will look at any of these that we want, absolutely, but I've got this one on the board, and the sooner we cover it, the sooner I can clear it off. So, this one is currently number 5. The number question it has might have shifted because while I can take questions out and add new ones in, I can't rearrange them once they're in. So the numbers change when I take things out and I can't move things around. sadly, without redoing the whole assignment. But in this physical situation, we have two wires hanging from strings, which is a weird scenario, admittedly, but two wires hanging from strings, and both of these wires have the same amount of electric current running through them. The first part of the question, if these wires repel from one another, is simply what relative direction must the currents be between the two wires. If the force between two wires attracts, the currents point in the same direction. If the two wires repel, the currents must point in the opposite direction. After that, we are asked to determine the current in each wire. And thankfully the question tells us that each wire has the same amount of current in it. It might be in different directions, but it's at least the same number. That means it's going to be the same variable I in all of our math, which will simplify things a bit. So we only need to solve for one total I. And what is physically happening here is when a wire has current running through it, it makes a magnetic field, and when the wire has current running through it, it is now susceptible to other magnetic fields. So each wire makes a field that exerts a force on the other, and they push apart. We need to figure out how much current is in each wire to cause this. The information that we are given includes the mass per unit length of the wire, which admittedly is kind of a strange variable, but the way that I interpret it and how I use that in the math, my numbers are a little bit different from the previous version I had on the screen. These wires have a mass per unit length of 44 grams per meter. If you have a 1 meter length of this wire, it has a mass of 44 grams. So for simplicity's sake, let's just decide these wires are 1 meter long, therefore they must have a mass, and your number will vary here, of 44 grams. Yes?
Are we gonna have a problem this ridiculous on our test?
Not planned.
I did it last night and like found someone on YouTube that had a really, really thick accent to explain it to me.
Yes, I know exactly what you're talking about.
And I like kind of got it, but I probably could not do it again.
Okay.
It's like a one-time wonder type thing.
I'm not planning this type of situation again, but every year this class is given, there's at least one problem like this on a homework assignment.
It's not fun unless it's hard.
It's not fun unless, okay, I'm not going to comment on that. I don't want it to be like, I don't want you guys to have to spend all day and all night on these things, because that's not good for anybody.
Amen, brother.
But this type of question does come up every so often. So, to start with, if we just assume we're looking at 1 meter of each wire would have a mass of 44 grams, 0.044 kilograms, and that's actually the only number that's going to vary depending on what version you're working. That's the only number in red text. So everything else will actually be the same, except for that piece. And each of these wires, when you turn on the current, normally they'd just be hanging straight down, but the force between them is pushing them further apart. And as a result, the wires are now, they're attached to 6 centimeter strings, and now there's an angle of 16 degrees between those two strings. The wires are now some unknown radius apart. In terms of the electric and magnetic things that are happening here, there are 2 formulas that are relevant. Now that each wire has current running through it, it's going to produce a magnetic field. That magnetic field depends on this constant, which is 4 pi times 10 to the negative 7th, times the current divided by 2 pi times the distance between the 2 wires. Now that that field is being created, that field is going to exert a force on the other wire. That force is equal to the current in the receiving wire times the field from the other wire times the length of the wire being acted upon. Since both wires have the same amount of current and the same length and the same mass, this is symmetrical. It doesn't really matter which wire you look at. One will exert X force on the second will exert X force back on the first. They'll be creating the same fields. We just have to look at one of them. The thing we are asked for ultimately is current. So in either of these formulas, we eventually want to solve for I. Within these formulas, however, we don't currently know the strength of the B field, we don't know how far apart they are, and we don't know the magnetic force between the two wires. And we're going to get two of those pieces of information through trig. Looking at the physical picture, these wires have been pushed apart from each other by, they're being pushed apart by the magnetic force, but there are two other forces currently acting on each one. We have gravity pulling down, force of tension pulling up through the string, and then the magnetic force pushing away from the other wire. We know how long the string is, and we know the angle between the two strings, which is enough trig to help get us started figuring out the magnetic force and the distance between the wires. I drew these forces here, and then this might be an odd way to do it unless you're me, and this is the way I've been doing it. I took all these vectors and redrew them as a right triangle. Tension going in this direction, gravity pointing down, magnetic force pointing this way. It might be a strange way to draw it, I fully admit, but all of those vectors do form this type of triangle. And just in case, is the tension's the only one on an angle. The tension's X piece should be the same as the magnetic field force, and the tension's Y piece should be the same as gravity. So it stands at least to reason to me that we could just draw the triangle like this. Getting a few varied glances, that's okay. This is a method that I came up with and has bewildered people. Is that a question? I'm just scratching my head. Okay.
Can you not just use the triangle with the 16 and 6 centimeters to solve for like the long line and get the radius?
You absolutely can. And that's exactly what this is. So this is a congruent triangle. This is a congruent distance triangle. This is a force triangle. So I took this picture and turned it into these two images. One for force, one for the radius.
You don't have to do
Sorry?
You don't have to do that part, or you do have to do that part?
The radius, you have to figure out through trig.
But you can't solve it from that first triangle.
Oh, up here?
Yeah.
You could. I know there's a formula for figuring out the metrics of an isosceles triangle. I just don't remember it. But you could absolutely, knowing 6, 6, and 16 degrees, figure out that bottom side using that isosceles formula. I just don't have it to hand. But that should tell me that I need to look it up. Here's this formula, the principle that I'm thinking of and not as easily found as I would have liked.
Okay.
And I use trig so much that I just default to it. So this is basically just half of the isosceles triangle. As such, the 16 degrees gets chopped down to 8 degrees. 8 degrees there, hypotenuse of 6 centimeters. And when we solve for the bottom of just this triangle, it's going to be half the radius between the two wires. And this number will be the same for everybody. The wires should, after finding R over 2 and then finding the total R, be 1.67 centimeters. The force from the above triangle will be a little bit different because everyone's going to have a slightly different mass of wire. Even on my own board, it's a little different because I had previous numbers the last time I did this. I had different numbers the last time I did this. Bless you. Bless you.
Is that a 9.8 in the parentheses?
Correct. Yes, it is. So,
Like, how did you get the FB?
good question. So, this triangle here that I've made between magnetic force, tension, and gravity, we know this angle, and that means we need one of the sides to figure out FB. And since we know the mass of the wire, we can figure out the force of gravity on the wire. So whatever mass you have from your number times 9.8 will give you the weight of the wire. That is then one of the two legs of this triangle. Tangent of the 8 degrees should equal opposite over adjacent. So tangent of 8 degrees will equal magnetic force divided by whatever your wire weight is. And using the 44 grams per meter on the board, I've arrived at a magnetic force of 0.0606 newtons, which will vary somewhat. But once we have that number in this radius, that's pretty much all we're going to need.
Can you go over the tangent of 8 in the formula thing? Because I keep getting a negative number when I type in.
Is your calculator in degrees? Just
Probably not.
checking real quick.
No, it's not.
Okay, that might have something to do with it.
That has something to do with this.
Does that answer the question you had? Sorry. Okay. Now, from that trig, we found two numbers, force, magnetic force, and also the radius between the two wires. Now, we can take that information back over here. We now know FB, we know 1I, we know L, we know R, 1I. We still don't know B. But you can get around not knowing B by simply plugging this in for B in the other formula. And that technically gets rid of the actual B variable. So, if we write out the formula and put this in instead of B, we arrive at something like this. And we do know this constant, it's just, I didn't write it up yet. How do you guys feel about this point onwards? Okay.
So you don't need to find the force of tension, you just need to find the magnetic force in your little chart for this problem.
Right, the way that I did it, I managed to skip finding tension.
Okay.
The long and proper way to do it would be to divide everything up into xy components. You know, sum of the forces of the x-axis equal blank plus blank plus blank equals 0, so on and so forth. I find this accomplishes the same thing in fewer lines of math. Bless you. And yes, with this new number, I get the 71.1 amps that this version of the problem is looking for. Which, as brief review, it's too much current. I don't know who built this or why. That's not okay.
I think this is gonna be easy to answer. I tried to find the gravitational force in a previous question and did it 2 different ways and got the same answer. What formula am I supposed to use?
The 2 typical methods for finding gravitational force are m times g if you are near Earth's surface and g equals 9.81. The long, drawn-out formal version is big G m1 m2 over r squared. This works for any 2 objects, regardless of if one of them is Earth and the other is at the surface.
So for the problem it is at the surface, so you can use either, and I used either to try to figure out why it was telling me it's wrong, because they give you the same answer.
Which question was it, sorry?
On my page, it's 4.
Okay. This is it still? Okay. At the equator near the surface of Earth, the magnetic magnetic field is 62 microtesla northward, and there's an electric field downward, like into the ground, 210 newtons per coulomb. Find the gravitational, electric, and magnetic forces on an electron with instantaneous velocity of so-and-so towards the east. So we're finding 3 different forces acting on this particular particle. The gravitational one, you should be able to use m times g. Did that not work for it? Well, that's frustrating.
Because it's a proton or electron?
It says
Forces
on an electron.
Oh, I'm used to mass of a proton.
Noted. Is your answer 1,000 times too small? And also, well, I guess I wouldn't tell you.
It just says it's very wrong.
Well, that's just rude.
I don't like when they do that. They're like, your answer is more than 100% different than the actually observed.
That's not helpful, though, sign.
But it is,
And then when it
according
says
to website.
10%, you're like, oh, I'm close, but you're just not.
No, it's usually not actually. It doesn't mean anything.
No, it just means you're wrong. That's all I need to tell you.
At the very least, the numbers aren't going to be too different, like the red numbers won't be too different from these. So your answers should be of a similar scale. Actually, gravity on an electron is the same for everybody, so this should be the answer.
Wait, what's the mass of an electron?
Great question. I think it's,
I just Googled it.
It
9
gave me a bunch of different.
it's a known constant, that's allowed.
times 10 to the negative 31
Is that in grams or kilograms?
kilograms.
Okay,
What
good.
is it?
That's what I got.
9.109 times 10
Drop off?
to the
Yes.
That is correct.
Yes.
Can we go back to the previous question for a minute? Because my response is within 10%, but
That don't mean nothing.
I'll need your last name and I'll check.
Just tell me I'm wrong, that's all I need you to do.
Wrong your last name, sorry.
ransom.
Thank you. I'm going to check what WebAssign thinks the answer is and compare it to what you just entered.
Yeah, I could live on both
Ooh.
sides when I get
So these last 2 problems, Lainey, are the ones where I wasn't focused.
Within 10%.
It's like perpendicular,
That's a very
magnetic.
close number.
Hat, turns.
I'm wondering if that's just rounding.
I went back and like did everything without
I
rounding.
think I was playing monograms.
Exactly.
So you really do not even scroll in a calculator.
You know what I do? Copies?
Yeah.
Honestly, I don't know.
You show me your work, just so I can.
Honestly, I don't know. It's probably the most relatable thing I've ever heard.
I absolutely believe you. WebAssign just is a turd.
Like,
sometimes.
calculate the value?
Yeah.
Oh, I haven't done it.
What is it?
This,
I think it's 66.08. Like, I thought the last homework was so easy, and this one is so hard.
I understand like the directions.
Yes,
like,
all this looks
where
good.
you
do the
look
right
at
hand
pictures.
For
I
the
can
sake
do
of
that part.
simplicity, I'm just going to tell you
The
WebAssign
rest
is
of this,
looking for
yeah, I can.
16.15.
Oh, wow.
It might have been something rounding in your calculator and WebAssign with like finding this force. That'd be my best guess. Bless you.
Thank you.
We started talking about force, so briefly back there for a sec. Everyone will have the same gravitational answer, but the electric and magnetic will differ slightly. The formulas at play here, yes. Force electric should just be the magnitude of the electric field times the charge of the particle. And force magnetic is based on the charge of the particle, how quickly it's moving through the magnetic field.
Is that big enough?
Oh, perfect.
Okay, I can't see, so I don't know, like, Is that for force electric? E times Q?
Yes.
Okay.
Value of the field times the charge of the particle.
I wasn't sure if it was an E or an underlined F.
Ah,
Never-
sorry. That's fair. My handwriting is garbage, and we're using both letters right now.
Self-aware man.
You can't improve on your flaws unless you admit you have them. What's that? First step is acceptance.
So,
The charge of an electron.
don't have that memorized.
Something
1.67
small,
times 10 to
something
the negative
negative.
19 coulombs.
1.67 to the negative 19.
Correct.
Nice.
It would technically be negative, but that only tells you the direction of the force. Try to throw markers. Okay.
Why is that wrong?
Great question.
Mine differs by more than 100%.
Use regular Teslas.
Yeah, at least for the magnetic, this is micro Teslas. Mine. That said, my electric is off a little bit, and I don't like that.
What number is the micro?
That's times 10 to the negative 6th.
Tesla's like like a large unit. Are Teslas a large unit or are they like really small?
1 Tesla would be, I think the force that, 1 Tesla would exert a 1 Newton force from 1 meter away, which is probably a lot. So yeah, 1 Tesla. 1 Tesla's pretty big. Most magnetic fields are significantly weaker than 1 Tesla. Should just be cute. Okay, you know what? My browser didn't universally reassign every single assignment to have a 10% window of freedom on the answers. So let me change that. Okay, the margin of error is bigger now, so hopefully that should help a little bit.
So if it's within 10%, it should be
Yes,
accepted?
yes.
Yes. Maybe it just is using a more precise charge for
Maybe?
the electron.
Just can't think of.
The solenoid question, did you take that out? I don't, also don't know if I said that right, sorry.
I did take the solenoid question out
Fine by me.
because it required you to make a couple unfair, subtle assumptions about the shape of the solenoid. Additionally, it turns out it turns out the charge is only 1.6 times 10 to the negative 19th. That would affect the answer.
Oh, there's no 7.
There's no 7. I think I'm conflating it with a different constant, possibly the mass of the proton.
So question, for number 2, Do you have to add like to the distance off the Earth? Do you have to add like half of the Earth?
Yeah, yes, you need to add Earth's radius to that.
If you Google it, it'll give you the right answer.
Why am I missing?
For Earth's radius?
Did it last?
Have you
Google was
read-
very nice to me.
I might need to manually regrade here since I made changes.
I have 6 check marks, but only 4 points.
Rude.
I don't think I went over my number of submissions.
Can you refresh the tab recently?
I shall refresh it now. Oh, this just raises all of my work.
So if we're finding torque and it's just making a circle, is N 1?
Yes.
Cool.
It only specifies one loop of wire.
So. I'm confused on which equation you use for number 2.
Oh, So 2, and subsequently 6 will utilize the same formula and principles. This is a case where a charged particle is within a magnetic field, and because the direction of the force is constantly changing directions, the particle is also going to constantly change direction and ends up orbiting a central point. So in the case of 2, that central point would just be the center of the Earth.
What's the formula?
Great question. So what's on the screen right now is a combination of the force that a magnetic field exerts on a charged particle moving through it, in addition to centripetal force. Because when the particle is orbiting in a circle, the force from the magnetic field is constantly pointing towards the center of that circle, acting like gravity acts on the moon. It's a centripetal force keeping it in its orbital shape. Make sure you have this copied at the forefront of your mind when we're doing 2 and 6. I'm going to work to myself real quick to make sure that all the methods match up correctly. Oh, I will also, in fairness, publicly list the radius of planet Earth as usable information here. The radius of Earth, yes, the equatorial radius is 6,378 kilometers.
Can you say it one more time?
I will even write it down. Radius Earth, 6,378 kilometers.
So do you use the mass of the proton or of the Earth?
Give me 1 sec. I want to check real quickly how much that matters.
I was working on 7, so
It's R equals AB squared over Q.
R equals N
M B squared over Q.
Wait, what problem are you guys on?
Squared over Q over. I just don't know if it's the mass of the Earth or the mass of the proton.
Oh, it should be the mass of the proton.
Okay.
Which I will also double check because I don't remember that one. The mass of one proton is 1.67 times 10 to the negative 27th kilograms.
Oh, that's not good.
So you
Okay.
have
Did you do five?
the numbers plus the radius of this.
Your response differs significantly from the correct answer. Rework your solution from the beginning and check each step carefully. Thank you.
Not helpful.
I'm working on number 7 if you are looking for a next move when you're finished.
Thank you. Appreciate the tip.
No rush though.
Well, that is not anything what I got. I didn't hear this one.
What the?
I got like a number with no exponent. Did you take it? I'm just not.
I tried number 7 again and it gives me the same response. Slaney, did you do 7? How did you do it?
Really? Yes. Wow. I got a number with no exponent again.
Yeah, I didn't get my exponent.
You just got like a whole number?
Yeah.
I don't know, maybe I think I might have found it.
I got a whole number, is it like a really long one though?
No.
Oh,
Mine's like.
I figured it out,
170.
but,
Yeah, I got like 180 something.
oh.
Yeah.
You guys did number 2, right?
Yeah.
Yeah.
I did the mass that gives you minus 1500
Okay, this like.
plus the
Wait, mass?
mass. Not mass, sorry, kilometers, the kilometers it gives you, sorry. Circle the earth.
tragic.
This is 11,000.
There's no wheels.
Minus 1500. And I added that to the earth's radius.
No, this is true.
Wait, why is
Like
it
trying to
1500?
Who?
Where his is 1100 kilometers. Right there.
Yeah.
That number, plus the Earth's radius, which was the 6378 kilometers. And then multiply that times the 1.6 to the negative 19. Times the 4.0 times 10 to the negative 8. And then divided it by the mass of the electron.
That's what I do too, but I'm getting the whole number.
Okay, there might actually be a problem with Levisine itself. Because when I work this, I get to the step of v squared equals blank. And the number I have for v squared is that number, not v. So there might be a problem with Levisine here.
Okay, so now.
I'm actually going to refresh this, change the number, and see what happens.
I got 7 drop off.
Got something right?
Yeah, I think I was,
Your answer was 7.
I think I was solving for the area rule. Not surprising.
Wait, did you guys change kilometers to meters?
No.
I had to do that. It went from like 78 to 7.9 times 10.
Oh, that is necessary. It'll give you the right answer.
Yeah.
Okay. All right, let's try again.
So mine ended up being 7.9 times 10 to the 6th.
Yes, stop.
Still got, a whole number, I got 5,491.
Yes. I got a value in 5.
Okay, so there is definitely a problem with Levisign here.
So do the one before it, like it's squared.
Yes, because I've reloaded this problem twice to get different numbers both times. And both times, the answer that Levisign is looking for isn't actually V, it's V squared.
Okay. Well then how in the world did I get it? Because I did not square it.
Well, in the form, like the
That
formula
worked
has,
for me.
sorry?
That worked.
The formula has V squared in it, so if you didn't take its square root, it should be correct.
Okay, yeah, I didn't do that. Okay.
But,
Okay, so we were right with the
We were right, it
5,000.
just,
If you took the square root of this number and solved for V, technically, that is the actual right thing to do. This is Skynet having a seizure.
Gotcha.
wow, I'm glad to know that I'm a little bit crazy. Okay.
Everyone's crazy in their own crazy way. I just wish that the technology didn't make this crazier.
All right, I'm gonna be real honest, I'm doing the quiz right now, and I just like don't understand the wording, because it's different than the homework. We're talking X, Y, Z axis instead of up, down, left, right, which is fine, except for I didn't get it the first time, so.
Is positive Z axis coming like out towards you or going up you?
So if something is
Towards you.
going directed along the X axis, it is going horizontal and flat on the paper. Okay? So and then the proton is going in the positive Y direction, so that means it's coming out of the paper.
So
Um,
what variable is kinetic?
Hang on.
That's a good question.
Okay. Whoever coded WebAssign is bonkers, or WebAssign itself is bonkers. So on the quiz,
I thought it was the other way.
So Z is into the page.
WebAssign thinks so, yes.
Whatever WebAssign says goes.
I hate this.
As do I.
Okay, so positive is going back.
That is, I got it right, but I
Yes.
flipped my positive negative statements.
Yes. That,
Wait, WebAssign's the one that thinks it's Z into the page, right?
yes. WebAssign says positive Z goes into the page.
Find the speed of the electron. Where do you need this right now? No.
The kinetic energy formula is going to play into this. It's just the normal, old-fashioned Yep.
Okay.
My M just looks like a
So
one.
then, to find the radius, is it just the B is equal to the mu constant I over 2 pi r? We don't know I.
It's actually simpler than that.
No. Okay.
The formula we used for 2,
Okay. So, R is equal
So
to-
that formula is not on our sheet, right?
that one?
The R equals,
It's supposed to be.
like, this one's on there, and this one's on there. But like, I'd rather write them down.
Charge an electron, no, I already
Sorry about that.
forgot.
But that's the two that make it, right?
Um.
So that's another truck.
Let's see if I.
Calculate the magnitude direction of this magnetic field in the region through which the current passes.
Sometimes I'm working and I forget what I'm doing while I'm doing it. Okay, for V squared, for V, did you get like a really big number that's not?
I was result for the previous,
How do you do
the challenge,
Because you've never used it.
using that when R is equal to N squared.
But you need V squared.
It tells me what 1/2 N squared. Because 1/2 N squared is 9. But you know what? Maybe.
Can you spell out another thing?
Yes.
Just so I can think my numbers in the ballpark.
You know?
So it is negative one, I don't,
An electron, mass of the electron is, well, let's make sure that the sign is actually giving you the right numbers and using the right numbers, because I'm doubting
If it
everything right now.
was,
Electron, kilograms is 1.
you said into the page is negative X, Z, or positive Z?
End of the page is positive Z from web science perspective. Okay. Okay, good news. The normal kinetic energy formula will give you the correct answer for 6A. And you just need to use this kinetic energy and the mass of an electron, which is 9.1 times 10 to the negative 31st kilograms. Then, with the velocity from part A and mass and charge of an electron and this magnetic field, we use the combo magnetic force centripetal force formula here to find the orbital radius.
That's like on me.
Yes.
Is magnetic field equal to B?
Yes. B is magnetic field. And
Well then,
I looked this up last time. I think it's because of Biot-Savart. It's just an interesting name for a human.
What are we using for N? The electron?
Mass mass of the electron, yes. So the charge of the electron, V is the velocity found in part A, B is the Teslas given to you in the problem.
The mass of electron.
And we're using 9.1 times e to the negative 31st.
Correct.
Rocco, please.
Negative, is it negative 1.6? For the cube, that's 10
The negative won't matter a tremendous amount because the machine wants a positive answer. Also, there's a squared in there.
Okay, the quiz, the learning quiz is negative.
There.
Because it just like, it's not where like the homework, so it actually is true. But if this is magnetic force per unit, whatever, then that is F. I'm looking for B because I'm looking for the magnitude and direction of the magnet. I'm looking for B in the direction of it.
Current in the positive x, perpendicular to the magnetic field, force per unit length is 0.3. Direction times the magnetic direction of the magnetic field. Okay, so that should just be F equals IPL. If we use 0.3 the length of 1,
Am I solving for B or F?
B. We're solving for B.
Not.
What you're doing here should be correct.
I thought you were saying answer. Right, we're doing it.
I guys are on 6B.
I got 14.
I
got-
0.7.
I got 2 times 10 to the 8.
Mine's different by more than 10%.
Mine is also different.
Mine differs significantly from the correct answer.
Are you doing the 9.1 times 10 to the negative 31st times the V you found squared
Yeah.
over 1.6 times 10 to the negative 19
Yes.
times whatever number it gives you for your magnetic field?
Yes.
Okay.
That's what I did.
Correct. What's that? Or yours,
Didn't
honestly.
accept it. And they just have
It's not
each.
like ours.
So
Yeah.
like,
Do you have to change
Does that,
something
what
with
are you
the
really
magnetic
doing the
field?
same thing?
This should be the unit of magnetic field.
okay, well
I'm
then.
triple checking myself.
I think this is the last one I have. She's not very good.
That's fair.
Is yours right?
No, I got 15.
Presbyterian College emailed me, what could they possibly want?
COVID
I think they
vaccine.
emailed us too.
So they want everyone to get the
They wanted
Why?
to get
It
much
says
heads
no.
up.
It says differs by more than 10%.
Yeah.
What, do you want to see my? I mean,
Was
this
yours
is
right
my
when you
work
resolved
program.
it?
Part A? Yes,
Part B, no, right?
correct.
Yeah, we don't.
I cannot explain what's wrong with part B.
What if you try not
Where-
squaring
Which
B
question
again?
is this?
Oh, you know what? If we try not squaring B.
Yeah, because last time we didn't square it. Or
So
something.
that should,
Okay,
No,
now that
yeah,
gets
like-
me to 1.6 e to the negative fifth. I don't think that'd be right.
Like 15.7.
no, that's it.
That is it? For part B?
It should be approximately. If you
Well, then
convert,
how's
once you
your
convert that to
answer?
micrometers, well, tell me
Oh.
exactly the answer you got again.
1.65 e to the negative fifth.
Yeah, so that would be 16.5 micrometers.
Oh my gosh, I hate this.
So for some reason, WebAssign is across the board ignoring the squared on that formula.
Yeah, that was right.
Wait.
Whoever coded this website, you know, I'm at fault here too.
Is there for sure a square?
There's, yes, the squared comes from the centripetal force formula, which has a v squared in it.
Okay. That
So
makes
it's
me feel
supposed to
better.
be there, but whoever coded WebAssign elected to ignore it.
Kind of like I like to ignore a lot of things here.
Fair.
Can't fault them for something I do.
I publicly apologize.
Okay, so I think maybe this is right.
Work.
My work can I change it?
Yes.
So, on our test, if we have something like this, should we just not square the paper?
I am going to hand bill, manually check and double check every test question before I put it up.
Oh, well, we're sitting here at work anyway, so it wouldn't matter, right? What was the
Yes, I will be seeing the work, and I'm grading based on the work and not what they're assigned.
Should I start the quiz now, or should I attempt it when I go?
The
It's
quiz,
not that hard.
quiz should be
If
fine.
you're okay with weird wording, slash asking.
I didn't know if you wanted to like go on and like talk about other things, or if we're just like,
There's a couple of things I'd like to address before we get to ends.
just what,
I just went on going on.
Hang on just a second.
Number 7 is the fourth.
Okay, everyone. I would like to officially apologize.
It's not your fault.
It's not your fault. And you're willing to sit here and work through it with us, so we're not mad at you.
Yes.
Seriously.
Thank you.
I would be furious if I was sitting by myself trying to figure this out.
Is that not on?
It helps my brain a lot, but
When there is technological issues, usually the professor just says, figure it out. So appreciate that you don't say that.
well, there wouldn't be any way for you to, because the game, the machine isn't playing fair.
See, you understand that. I
That's
don't
what
think
I'm
The
everyone
machine is
does.
batting 1,000 and gives you a wiffle bat.
The professors that blame me for the system not working, that irritates me.
Go ahead and say his name, Stuart Gordon.
Take
So-
but.
I will be, I already have the test draft, but I'm going to be manually checking, rechecking, and re-picking every single question to make sure that things are fair and correct. I will also be posting, I'm still modifying it slightly, but to go ahead and show you the rough draft, I just needed a picture. Why did I need the picture?
Yes, that.
A list of all the formulas and concepts to be familiar with before the test next week. There's more on here than will be on the test. I'm trimming, but this is to give you an idea of the list and all the formulas. I'm going to be pulling some things out. Your list will be shorter. Don't let a couple mysterious things you haven't seen before alarm you.
But we don't need to memorize those, right?
No, this is simply the list of things to be familiar with, and you can also use this as a formula sheet.
So we can't use ours.
Yes, this is a study list and a formula sheet that will be on Brightspace once it's finished and shortened.
Okay.
Thank you.
I will also be posting practice questions and shortly after an answer key for them. Next week, during lecture, we'll be studying and reviewing and answering any questions you have. You don't have to take the test until you're ready. And
Lady Night present on Honors Day if you want to
And
watch
Jess.
us. And Jess, sorry,
Oh,
Jess.
and Paris is in your test.
And Paris.
Oh,
Everybody-
yes.
You should come to Honors Day.
You should.
I won't have lectures on Honors Day. Is that all online?
Yeah.
Okay.
At 8:30 in the morning, sorry.
Like really
We're
late.
here.
We're like 3 o'clock.
Yeah, we're so late. I was like the last
Well, I can do it from my
Us two
living
are
room,
like-
so sure. Before we break, do you have to go somewhere now?
No,
Okay,
I just had to finish some work stuff. I quizzed.
that's fair. It's kind of, I find it kind of funny that I think the assignment with the most mechanical issues is the one about magnets. Because magnets is one of those things in physics that we still don't really get. A primary example of which is called magnetic flux. Basically, whenever you take a magnetic field and force it through a solid object, weird things start happening. This is aluminum. Aluminum is not a magnet or magnetic at all. So right now, this is a iron magnet stuck to the board. This piece of aluminum doesn't stick. This aluminum tube doesn't stick. Nothing. And so this acts as expected. But when I put a magnet in there, and suddenly there's a magnetic field being pushed through the aluminum, even if the aluminum itself isn't magnetic, by pushing the field through the aluminum and then making the field move, changing it, the universe kind of glitches a little bit.
I feel like I'm at a magic show.
How are you?
Science is just magic that we have an explanation for.
Is it
gonna
come out? Like, are we ready?
Are you gonna get
Give
it?
it a sec. It's near the end.
Can you-
Well,
So I have some questions.
Yes. So does every physicist.
Oh, so there's not actually.
This is an example of magnetic flux. Whenever you create flux by forcing a magnetic field through a solid object, and then you change that magnetic field, you get a change in the amount of flux produced. And whenever flux changes, the universe has an aneurysm.
Me too.
There. Different example. This machine up here is an electromagnet. This copper coil is wrapped around an iron core, and when you run current through it, it becomes a magnet. But only when I'm throwing the switch. Under normal circumstances, not magnet. These rings are aluminum, so again, still, every human uses a magnet. No magnet. Not magnetic in the slightest. But when I throw these rings onto this electromagnet and turn the magnet on,
Oh.
Oh.
I have two rings. It's also warmer. It gets a lot of energy from this.
so, wait, do we know what's making it go away from it?
Whenever flux changes, and so when I put the ring on here and I turn on the magnet, magnetic field travels through the aluminum, that creates flux.
What is flux?
Flux is just a measure of how much magnetic field passes through something. It's a very weird measurement, admittedly. It's just magnetic field per surface area. So the more magnetic field, the more flux. The bigger the object, the more flux. Actually, the bigger the object, the less flux. Point is,
Can you do them both at the same time?
I can. I'm just not very dexterous.
It looks like it's just like repelling it really, really fast.
Yes, so this is actually an alternating current system. So when I first turned it on, the current goes one way, the magnetic field goes one way. Then 1 millisecond later, the current switches directions, so the magnetic field switches directions. Magnetic field changes, the flux changes, the universe hiccups. Whenever flux changes, you get some amount of force. And we don't know why.
Will we ever know why?
All of physics is technically just our best guess. All the things we've been studying is written by humans. It's inherently therefore flawed, and every new textbook is just a slightly better guess. But because we didn't make the universe, and because we have squishy meat computer brains that are fallible, we'll probably never know everything. And so, no, I don't think we might ever figure this one out, frankly. Not this side of heaven. So all this to say, magnets are weird. It's okay if this is hard. It's hard, as a matter of fact.
Amen, brother.
So you have
I do. There's no lab today. So everyone have a good day. The assignment will be due tomorrow, just to give you the extra breathing room. I'm going to shut the camera off. Have a wonderful day.
Have a good day.
Thank you.